Hello and welcome back to Higher Maths Functions and Graphs Graph Transformations, and today we are going to have a look at scaling, which is essentially stretching or compressing graphs. So far we've looked at translation, which is moving graphs every point on the graph up and down, looked at reflection, and in particular reflection on the x or the y axis. So now we're going to have a look at scaling. So again, we're starting off with these two graphs. So we have a sine graph and we have a cubic crossing at -1 and 3 with a maximum turning point of p comma q. And so to scale vertically, to stretch vertically, kf of x scales a graph of f of x in the vertical direction. So remember, this graph had a maximum turning point of p comma q. And if we look at the graph of 2g of x, so it's going to be twice as high, it's going to be stretched by a factor of 2 vertically. Rather than a height of q, it's going to be a height of 2q, which is just double what it originally was. If we're looking at y equals a half g of x, it's going to be half as high. So rather than a height of q, it's now at a height of a half of q for that maximum turning point. So we have met this before at National 5. So hopefully we remember that y equals 2 sine x is the sine curve stretched to a height of 2 and a minimum height of -2. And we're at y equals 1/2 sine x is a sine curve. Oh, that's wrong. That should be 1/2 and -1/2. There's been a mistake in the HSN notes there. So that should be 1/2 and -1/2 for y equals a half sine x. A negative value of k causes the same scaling, but the graph must then be reflected in the x-axis. So let's have a quick look at 2g of x again. So here's 2g of x. If it was -2g of x, I would essentially flip this curve or reflect this curve in the x-axis, which, as we can see, it does. Right, so that was vertical scaling. Let's look at horizontal scaling, which again, we have met at National 5. So sine 2x compresses the sine curve by a factor of 2 towards the y-axis. So rather than one complete wave being 360 degrees, one complete wave would be half as much because it's scaled by a factor of 2 towards the y-axis. So the wavelength would only be 180. And y equals a half sine x is stretched out by a factor of 2, or we are only getting half a wave in 360 degrees if we want to think about it that way. So y equals g of 2x with a cubic compresses the graph by a factor of 2. Y equals g of a half x stretches out the graph by a factor of 2. So let's have a look at a couple more examples. And sorry, one more thing. G of -2x will compress the graph by a factor of 2 and also reflect it in the y-axis. So let's have a look at a few more examples. So we've got y equals x squared. So y equals 3x squared. We'll stretch that graph vertically by a factor of 3. So all of the y coordinates will be 3 times as high. So here we had -1, 1. So here we will have -1, 3. And let's have a look at a cubic as well. So we have the cubic there. Now y equals a half of x cubed minus x. So it would only be half as high for each of the x coordinates. There we go. And if we wanted it even smaller, we'd try 0.1. And again, if we wanted to stretch it rather than squashing it a bit, we'd maybe go for 5 multiplied by x cubed minus x. And we have the parabola. So let's look at so we've got y equals x minus 2 all squared. So f of 2x will compress by a factor of 2 towards the y-axis. There we go. Now f of -x reflects the graph and the y-axis. So f of -2x, so just replacing every x with a -2x will give